Hello, I am Thomas Fleming from the InnovAIte Capstone Company, one of the companies that were part of the Deakin Capstone program in Trimester 1 2025. So InnovAIte is a new capstone company which aims to trial and validate some different AI tools and methods to find out how those can be used to assist Deakin's upcoming entrepreneurship programs. This trimester, our mission was to basically understand how these AI tools can ease the startup development cycle in two main ways. So by significantly shortening the development cycle and also limiting the amount of technical expertise required. So if you don't have a bachelor's in IT, you don't have a master's in IT, you can still make websites for whatever entrepreneurial ideas you might have. The company was divided into two main sections. So we have the AI Prototyping Lab and the AI Generalist program. We'll go more in depth on those later, but the AI Prototyping Lab, in short, it's basically just trialing a wide variety of different AI tools, seeing which ones are better at what, how they differ from each other. The AI Generalist program was more so trying out AI tools in a wide variety of situations, a wide variety of use cases. So AI for research and development, AI for student success, stuff like that. And then we have the core leadership team. So the core leadership team for Trimester 1 2025, we had Jesse McMeekin, he was our product owner. We had Dr. Leon Yang as our company director, and we had Scott West as our industry mentor. So InnovAIte operates with three core functional areas. These are code, communication, and coordination. And each of these core functional areas have a leadership team associated with them. So for communication, we have the communications leads. The communication leads manage the communication between the leadership team and the rest of the company via posts on Teams, and they also manage the creation of the company-wide on-track submissions, so writing the bulk of the reports, but also making sure that everybody is contributing their necessary contributions to the company-wide reports. They are overall responsible for ensuring everybody in the company understands what they need to do for the upcoming weeks and also communicating with certain members when that is needed. For coordination, we have the sprint leads. So the sprint leads are responsible for handling the planning of activities and tasks using Microsoft Planner. They are also responsible for working out whether the usual Agile Sprint framework is relevant for our company, or whether an adapted framework would work better with our AI-driven work, given that we are able to develop programs and websites at a much more accelerated rate thanks to our use of AI. Finally, we have the code integration leads, which is from the code functional area. So the code integration leads manage the company-wide GitLab repository, and they're also responsible for evaluating the AI coding tools, establishing best practices, integrating outputs from multiple tools, and managing the handoff between AI-generated code and human refinement. So the AI Prototyping Lab and AI Generalist program, of course, did different things, but the general structure for both was the same. In phase 1, we had a research phase. This was more about investigating the tools or use cases, resource development, and just general knowledge building. And then for phase 2, we wanted to implement our newly gained knowledge into the creation of programs, projects, websites, videos, helpful instructional tools, stuff like that, just implementing our knowledge in order to create stuff. So for our two projects, we have the AI Generalist program. This was the program that was focused on developing resources and workshops for the broader Deakin community, sharing the AI knowledge with non-technical users. The aim was to develop an understanding of how AI can be used in different situations, both in university and business environments. And this understanding will then be applied to create educational tools such as workshops, videos, and frameworks, as well as being used to guide the InnovAIte 2026 project. Then we have the AI Prototyping Lab. This project follows a hands-on learning and teaching model. Students investigate a wide variety of different tools and then share their knowledge with the team. The aim of the AI Prototyping Lab was to develop a comprehensive understanding of a wide selection of AI generative tools, and this understanding was then applied to create projects and presentations to further demonstrate that knowledge, as well as create lasting explanations and examples for others to use. So now we will move on to learning a bit more in depth about both of these projects, and we will start with the AI Generalist program.
Hello, my name is Arun Sharma, and I'm one of the sprint leads for AI Generalist project. In this section, I will walk you through each focus area and what the teams have worked on throughout the trimester. There are 10 different focus areas, each contributing to research and development of AI tools. These are ChatGPT Claude for academic writing, AI for research and data analysis, Midjourney and DALL-E visual content, AI enhanced teaching tool, administrative AI applications, AI for student success, prompt engineering fundamentals, AI ethics and academic integrity, AI for industry collab, voice and multimodal AI applications. In phase 1, we focus on AI tools research, instructional video, resource package, and case study. In phase 2, we focus on project proposal and documentation, tool development, tool refinement, and testing and validation. Focus area: ChatGPT Claude for academic writing. In phase 1, the team explored how ChatGPT and Claude could assist with academic writing tasks such as brainstorming, paraphrasing, and drafting research papers, essays, and literature reviews. In phase 2, a thesis generator was developed using Cohere API. This tool aims to help students create strong thesis statements for academic papers. The next steps for this team will focus on expanding this tool into a full academic writing assistant, integrating advanced features like essay structuring and graph development, and conducting extensive user testing across various academic levels. Focus area: AI for research and data analysis. In phase 1, the focus was on evaluating AI tools for literature research, summarization, and data interpretation. The team also created standardized evaluation templates for assessing these tools' capabilities. In phase 2, a personalized research assistant web app was developed to assist researchers in managing their work. The next step is to refine the app's functionality and the user interface based on feedback from real researchers, ensuring that it fully supports academic research needs. In phase 2, LearnLens project was developed to assist students creating visual content relevant to their academic needs. The next step is to resolve integration of DALL-E API, layout issues, and finalizing visual outputs tailored to specific subjects such as history and science. Focus area: AI-enhanced teaching tools. In phase 1, the team researched AI tools that could assist educators with lesson planning, creating assessments, providing feedback, and automating repetitive tasks. In phase 2, workshops were conducted with Deakin faculty to introduce these tools, and feedback was collected to improve their implementation. The next step is to work on expanding the tool's reach, gathering more feedback, and measuring its long-term impact in classrooms across different academic disciplines. Focus area: administrative AI applications. In phase 1, the team focused on researching AI tools for processing, automation, documentation management, and scheduling, especially aimed at improving administrative tasks. In phase 2, a workflow automation prototype was developed using Node.js and integrated with tools like Google Calendar, Microsoft Graph, and OpenAI. The next step is to enhance the backend logic, develop user interface, and test the tools with real administrative teams to improve efficiency and usability. Focus area: AI for student success. In phase 1, the team created a range of resources aimed at helping students succeed, including guides and instructional videos on AI tools for academic planning and study aids. In phase 2, the team developed wireframes for AI tools to support students in various aspects of their academic journey. The next step involved converting these wireframes into an interactive web application, gathering student feedback, and integrating the tools for broader use. Focus area: prompt engineering fundamentals. In phase 1, the team researched various prompt engineering techniques, including zero-shot, few-shot, and chain-of-thought prompting, and developed a prompt-optimized cheat sheet for their teams. In phase 2, they developed workflow and templates for academic and administrative use, helping to structure prompts in a way optimize AI response. The next team will scale these libraries for more complex use cases and continue refining the prompt engineering tools for broader app adoption. Focus area: AI ethics, academic integrity. In phase 1, the team explored how AI could be used responsibly in academic settings, focusing on ensuring academic integrity through ethical AI use. They created a thesis title generator that incorporates ethical guidelines to avoid plagiarism and ensure academic honesty. In phase 2, the tool was tested and the user feedback was gathered to improve its functionality. The next team will focus on expanding this tool, adding more features to customize the generated titles, and incorporating more user feedback to refine the ethical guidelines further. Focus area: AI industry collaboration. Focus area: AI for industry collaboration. The team researched on how AI tools could improve collaboration between academia and industry, focus on project management, communication, and collaborative research. In phase 2, the team developed Collab Hub AI, a platform to bridge the gap between academic and corporate sectors. The next team will finalize the platform's features, conduct industry testing, and expand its functionality to more collaboration scenarios and tools. Focus area: voice and multimodal AI application. In phase 1, the team investigated voice and multimodal AI tools, focusing on their use for transcripts, accessibility tools, and multimedia creation. In phase 1, the team investigated voice and multimodal AI tools, focusing on their use for transcripts, accessibility tools, and multimedia creations, aiming to enhance the educational experience. In phase 2, they developed Socratic Crumbs, a chatbot with voice and vision capabilities and voice interactive storyteller to facilitate creative interaction. The next step will including multilingual support, improving real-time story generation, and further refining the tools based on user testing. Thank you for taking over the work on AI Journalist project. The foundation work has been laid, and the next team will continue to refine and expand on its progress made in each focus area. I'm confident that with your efforts, these tools will successfully be implemented and scaled across the university to enhance both educational and administrative processes. Best of luck. Thank you.
Hi everyone, I'm Albert, and I'll be walking you through our work in the AI prototyping lab. This lab was focused on hands-on learning and building using AI-powered no-code tools. Throughout this trimester, we explored tools like Lovable, Cursor, Bolt, and Windsurf, with the goal of seeing how far these platforms could take us in building real working prototypes. We didn't just test tools, we created and showcased functional projects, supported one another through workshops, and produced documentation and demo videos. Our work was structured in 3 main objectives. First, to explore and evaluate AI generative tools. Second, to create demo projects and useful company platforms that go beyond theory and actually solve problems. And third, to build long-term assets that support future hackathons and incoming InnovAIte teams. This structure ensured that our learning translated into real contributions, not just academic exercises. During phase 1, the focus was deep research and experimentation. We formed groups and were assigned specific tools to evaluate. Each group created a 15-minute video demo, a detailed write-up explaining how the tool worked, and a comparison against similar tools. We also submitted purchase proposals to recommend which tools should be licensed for further development in phase 2. Based on this, tools like Cursor, Bolt, and Superbase were selected for deeper investment. From phase 1, we learned that every tool had its own strengths and trade-offs. We found that tools like Bolt were excellent for non-technical users because of their drag-and-drop UI, but had limitations in flexibility. On the other hand, Cursor, when combined with Lovable, offered deeper technical control, perfect for users who wanted to tweak and build scalable logic. We finalized our research and shared everything via videos and documents for future reference. With research complete, phase 2 was all about applying what we learned to real-world applications. We developed team projects using the tools we had selected. This phase demonstrated our ability to deliver working, practical applications with minimal code. We learned how to build quickly and independently, and the variety of projects created shows just how adaptable these tools are. We now have a solid technical foundations to build on next trimesters, and tools like Bolt, Cursor, and Lovable are now central to our ongoing development strategy. We moved from experimentations to executions, putting AI tools to the test in live environments. One of our projects is NoCodeGem.ai, a platform built to help InnovAIte organize future hackathons. It includes user login, XP tracking, daily and weekly challenges, a leaderboard, and challenge submission features. We use Superbase for the backend and plan future features like admin panels, judging modules, and project review dashboards. Next is the InnovAIte website, our central hub and internal dashboard. It includes a landing page, team bios, logs, and flocks, all integrated into a Superbase database. Feature upgrades include AI-generated content, Microsoft Teams syncing, and analytics modules. This site not only gives us a public face, but also serves as an internal knowledge base and collaborations platform. In its early stages, the site was built using React with a MongoDB backend. But this setup caused loading issues. Based on this, we plan to migrate to Superbase for faster performance and better integration. We also aim to enhance the UX using AI-generated feedback loops and improve responsiveness across devices. Skill Quest Sprint is a self-guided learning tool designed to help users master a skill in 30 days. It includes structured challenges, a dashboard with a sprint calendar, and filters to organize content by category and difficulty. There's also a practice area with quizzes and small projects. This prototype was a strong example of combining UI logic, backend services, and AI-generated guidance into a cohesive product. Beyond group work, many team members created impressive individual projects. This included CarePulse AI for age care, AI resume tailor, student support dashboards, game and trivia tools, and much more. This project showed our team's creativity and how AI tools could be applied across different domains, from education to well-being and entertainment. If you're interested in our projects or want to explore collaboration, please get in touch with us or the InnovAIte leads listed here. Thank you so much for listening, and we hope this gives you a clear sense of how far you can go with AI prototyping and teamwork in just one trimester.